We have 3 speakers today. First is going to be Mrs. Wang, followed by Takahashi-san and Miyamoto-sensei. With this, I am handing over to the presenters. Please. An applause, please.
My presentation quickly, and nice to meet you. Hope you can enjoy this presentation here. Actually, I used to think maybe I can share my screen, but instead of it, maybe I just talk in this by this screen, and I will ask my members to handle the slides progress. Thank you very much.
Okay. Change screen. Please change screen to presentation screen. Okay, thank you. We'll make presentation titled IOC-DREAM, IOC Distributed Environment and Automating Response based on MISP. Presenter is Yifan Takahashi, and I'm Miyamoto. This is full of today's presentation, beginning with self-introduction and ends with future work. Introduction. We are the member of NTTDATA-CERT. NTTDATA-CERT is the CSAT of NTTDATA Corporation headquarters, established on July 1st, 2010 in Tokyo, in our company. Handle internal incident response over 50 years. Sometimes handles incident related to our customers. And author of this presentation is Yifan. She joined NTTDATA-CERT from 2017. Mainly worked on IR incident response, OSINT, SOAR for 6 years. Fukusuke Takahashi, he joined NTTDATA-CERT from 2018. He also worked on IR, OSINT, SOAR for 5 years. And me, worked at NTTDATA-CERT for 30 years, beginning of NTTDATA-CERT, and one of speaker of 31st Annual FIRST Conference in Edinburgh. Why we choose MISP, I explain. This is our old workflow, our traditional workflow in security operation. This is the workflow to IOC handling. Firstly, input. Input is made from email, suspicious emails, Zoom detection. But this input is made manually. And process. Secondly, management, IOC management. IOC management, in IOC management, we used spreadsheet like Microsoft Excel. But over 10,000 of IOCs using spreadsheet makes processing too slow. When I open IOC management sheet by using spreadsheet software, I had to wait a few minutes only to open. It's too slow and very stressed. output, and this is the distribution of IOC to other company, other organization. This is output is made manually. This is very stressful work. Input, management, output, all of the process is made manually. Full process is very stressful. Hi. And we have to automate this process, full of these processes. And this is the old workflow. We spent to process these IOCs input n day, n plus 1 day processing, n plus z is the output. At least we spend 2 days to treat IOC input from input to output. This is too slow to responding to incident and preventing incident. It's not efficient. And while we distribute IOC, some incident may happen, some company, somewhere. It's not good. And IOC sharing, real-time IOC sharing was required. Many of our company guys. Then we decided to use MISP to share IOCs. This is a MISP overview, but as you know, MISP is mainly used for information sharing, IOC or other information sharing, and we use MISP for information sharing. And I don't speak these things detail. These detailed things. We fail to benefit of MISP integration in our group. We can optimize SOC workflow and implement SOC automation. This is one of our benefit. Benefit 2, expand available. Yeah. Benefit 3, we can solve time lag problem in incident response or other emergency cases for information sharing. We spend n day for IOC sharing, but by using MISP, we can share IOC as soon as possible, automatically shared. Next, what do we implement? This explanation was made by Yifan. Yifan-san, okay?
Okay, I'll take it. Okay, so from here, let me introduce that what we implement, because based on the previous issues, we designed and implement a workflow like this. And you can see in the input phase, in the left, we create multiple Python scripts to collect IOCs from multiple sources, and like with API integration or like browser crawling. And we choose Jenkins to manage those collection jobs. And also we use Jenkins to make the job integrations with other jobs for enrichment or like SIM detection check. And for those enriched IOCs, we just used the official Python API, the PyMISP, to upload the data, those IOCs, into our MISP instance for management. And also, you can see as a part of security operation, we just we regularly extract the IOCs from MISP and also output to other devices like network devices. And currently, we implement the real-time deploy on our SIEM and the weekly update on our firewalls. And also based on the MISP default sharing functions, we just share our IOCs to other opcos MISP instances in near real time after we upload our IOCs into our instance. And you can see with this workflow, you can say it's like a little mature model. It is already a little mature model. With this model, with this workflow, we resolved the previous manual work issues and implement over $35,000 per year, like cost reductions. And also this workflow was released on 2019, and it has been a stable daily security operation workflow for almost 4 years. Next slide, please. Thank you. So here is a screen capture of our Jenkins management console. You can see its job here, and the order is like this. Thank you, please enter something. Yes, so at first we extract and collect IOCs from different sources, and second, and we process them with formatting for MISP, like MISP format, MISP event, MISP attributes, like that. And after that, we implement the enrichment with other services like SIEM, like some search engine, like some sandbox, something like that. And then we upload them to our MISP. After the upload process succeeds, after the job succeeds, the next job will run automatically to share the IOCs, to share the uploaded IOCs to other opcos MISP instances in near real time, because there will be some time lag between the upload job and between the share job. Okay, next slide, please. Thank you very much. So then let me talk some details when we integrate with others. Okay, so for us, NTTDATA-CERT, we use MISP to collect and integrate with other services for the automatic process. But besides them, as Miyamoto-san just mentioned, we need to integrate with other NTT data companies. And also out of NTT data, we also integrate with other NTT group companies. So, okay, so press once. Thank you. Thank you. So you can see this architecture. We need to integrate with multiple companies, like the same group companies, the different group companies. So that makes our integration architecture as multi-layer and also complex. When we share our IOCs with them by manual work, as previous, we need a lot of point of contacts, and we will spend more time on discussion, on confirmation, on negotiation. And so instead of manual work, we prefer to MISP to implement the automatically threat intelligence sharing. In this case, the point is to determine the point of contacts and the sharing method. How do you share it, and also how the data flows, the data flow in advance. That it is necessary. It is also necessary to ensure that the IOCs will be shared to the proper destinations without unexpected disclosure. So based on this architecture, we designed the data flow based on TLP tags and implement the automatically threat intelligence sharing via MISP functions. So let me introduce our data flow with next several slides. Okay, next please. Thank you. So first, the TRP red. So maybe you can see that the TRP red means no further disclosure. So we think that the IOCs of TRP red would not be shared to outside of each instance on MISP. You can set the distributions as your organization only and just do not publish it. And also as a backup setting, add push rules for the connected instances will also be a good solution. Yes, here is a short animation here. You can see the red one just stop it on their local instance. And next slide, please. Thank you. So the second TRP Amber. TRP Amber is for the IOCs with limited disclosure. We define it as that IOCs of TRP Amber will not be shared to outside of NTT data group. So by setting the push rules and the distributions, the IOC can be shared within NTT data group and be stopped at the ID line and be stopped for further sharing. Next, please. Thank you. So the next TRP green. So as you know that TRP green defines a wider scope than TRP amber. In our design, we also expand the sharing scope from NTT data group to NTT group. So IOCs of TRP green can be shared to NTT group companies, but not outside of NTT group. On the other hand, that in the definition of MISP's distribution, the connected communities will only send data to until 2 hops further than the local instance. Okay, one press, please. Thank you. You can see it is just stopped, and if you want to share it further, you need to reset the distribution each 2 hops, like to change the distribution here and to forward the IOCs to other NTT companies. Yeah, like this. And you change once, and if you want to share it further, you need to change it once again. Yeah, thank you. And finally, TRP white. Actually, in TRP 2.0 released on last year, this will be equal to TRP clear. And both of them are defined as that no limited on disclosure. So actually, in practice, we don't need to add any additional control on it. Just set the contribution as all and publish it. And also, if you set a lot of push rules to the connected instances, maybe it is necessary for you to check if the push rules is set to allow the IOCs of TRP white or TRP clear shared to all connected instances. That will be a filter, and if you set it up, even it is marked as TRP white or TRP clear, it will be stopped by the push rules. Okay, my part I think is here. Thank you very much.
Yeah.
Next, Takahashi-san, please.
Thank you. In this part, we will explain how we respond to the real threat, which was popular in 2022 and named Emotet. Here is a timeline which includes Emotet-related news released on Japanese news site and Emotet-related email reported to NTTDATA-CERT. When Emotet compromised cases increased in Japan, you can see these cases in orange. Reports to NTTDATA-CERT also increased at the same time. We noticed Emotet came back and we decided to start automated collection of Emotet threat intelligence and deploy them into our workflow to prevent further attack. Let's talk about the implementation in more detail. To combat Emotet threat, we developed a script to collect IOCs via the WCH API automatically. We choose field tracker to collect emotet-related IP address and correct emotet-related URLs from URL house by filtering tag emotet. In fact, there is an also standard feed of abuse.ch on MISP. Events are created for each malicious URL, but in our original script, we also extract domain and IP address from URLs as pre-process. And we segment our IOCs that one inventory has 1,000 attributes to ensure our response efficiency via MISP API. By our script, we implement more flexible customization. Besides domain IP FQDN extraction, we also use MISP to add citing on the malicious domain IP to mark the online-offline status. It can help us implement visualization and do further evaluation to review the response. So within this response, which source most contributed to prevent emotet attack? We evaluated several sources used in this case as review. Unfortunately, only abuse.ch is most effective against emotet. We confirmed emotet malicious traffic within the reported mail can be all blocked because the IOCs can be collected from abuse.ch in advance. This case is a good example of the effectiveness of our automated workflow with Jenkins, MISP, Python, that we can prevent real attack almost in real time from IOC collection. From here, I would like to introduce our plans for future work. The circle on the right is the threat intelligence process introduced by the US Joint Chiefs of Staff. A standard threat intelligence process consists of the following 5 phases: planning, collection, processing, analysis, dissemination. Continually evaluating and improving this cycle enables an effective threat intelligence process. We, NTTDATA-CERT, focus on an IOC management and target to implement this process on daily security operations. Based on our current security operation, we drew a 2D image for each phase. There are 5 main points. The first is planning. Based on the analysis of a threat trend, establish a plan for IOC collection and management. The second is the collection, implementation, automation of IOC collection. The third is processing, store IOCs as standard format like sticks, JSON, CSV, and enrich them with other integration. We merged analysis to planning, so the first is dissemination. Distribute the right IOC for the right device. And finally, we back to planning, evaluate performance of each IOC, and start another cycle. We, NTTDATA-CERT, would like to incorporate an IOC metabolism activation model in near future to address the gaps between to be and as-is by activating the metabolism of IOC. We aim to improve the quality of IOC and respond quickly to threat trend. Thank you for listening.
All right. So I saw a lot of you were taking pictures of the slides, so I suppose there are a lot of questions as well. So, all right. I'll start off with questions from my side. So the IOC collection sources, can you reiterate again, what were the, and how many IOC collection sources can you support? What types do you support? Is that any open source data that you can filter and parse and then later validate and feed into the MISP can be as a valid data source?
Sorry, how many?
So how many
Yeah.
data sources and what types of data sources do you currently feed in?
Oh, okay, let me answer these questions. Actually, we are collect the IOCs from multiple types of sources, and not limited to the open source and also the commercial services. Actually, we collect the data from open source one by OSINT, and you will find some IOCs from some open source site and some news site, and also some forums. And except that, we also collect the IOCs from some community like JP-CERT and something like that, and like some those community. And also, we are collecting IOCs from FIRST. So actually, when we choose the source to collect our IOCs, yes, the difficulty is one item that we need to evaluate it on the source. But actually, if the data is enough valuable, we are going to considering and working on the IOC extraction. And you can see there is a process before we upload and before we enrichment. That phase is the one that we work on the not so standard types, not so standard format that we collected from sources, and we compress it to format to the types that MISP can support it. Is it enough? Thank you.
Thank you for the presentation. My question is, when you have a false positive, do you use the same MISP framework to propagate that, or you have something else? What are you using to revert, for example, some of the IOCs?
Yes, good question. Should I answer it? And maybe Miyamoto-san and Takahashi-san can have some comments on it.
Yeah, to prevent false positive. Sorry for my poor English. We use an original allow list from proxy logs count, and when we input MISP IRC, and then at the same time, we check the proxy log counts in company. So many, the IRC domain and IP, so many access is automatically removed to the block list. That is one of the method. And other is, we have an original allow list to prevent false positive, like Google and Amazon also. And we have a plan for further prevent false positive to use MISP warning list for the future. That is our prevention for false positive. Thank you.
All right, from my side, a question. I mean, you've invested a lot of time in creating the scripts and automation. Is there any part that you can share with the community, unless you're already doing this? Sharing what you've done with automation? Unless you're already doing that. To community, correct. You have Python scripts, you have Jenkins automation. I'm pretty sure that it might be, unless you're already doing that, that might be a valuable addition to the community to kind of follow maybe similar steps, unless that's a chef's secret sauce.
Yeah, we haven't yet uploaded these scripts currently, but in the future, maybe we will upload and share these technique for other team members. In group company, we share each other the automatic automation script, but I think we think we can share more widely version our knowledge.
In addition, our programming scripts is not so high quality for internal use because we use our internal use. And to disclose to publicly, we will review our products, scripts, program, and other data. And please wait for a while.
All right. All right, thank you.
Let me have some additional comments. That actually, I'm also the author of the program, so I won't say my program is not good enough. But yes, but actually, here we share our work, we share our experience. Is that we wanted to share this idea and to share this workflow to everyone here. And actually, the script, the program is not the main point. The thinking, the design, the workflow is the main point, I think. And actually, in the program, I just use the default PyMISP functions, and also you can find the you can find the MISP on GitHub, and you can find several community there. They will maybe sharing their experience, and also if it is possible, we can have a discussion that if our program can be shared on there or on some OSS sites, something like that. So don't say my program is not good enough. my program is perfect.
Unfortunately, the whole cybersecurity industry is based on hacks around. But with this, let's thank the speakers. Thank you so much for the talk.